In this video, I'm going to go over examples of verifying trig identities. Let's start with the first example. Prove the identity that cotan x minus cosecant x times cosine x plus 1 equals minus sine x. So to start, I'm going to start with the left-hand side of the equation. I'm going to abbreviate that with LHS. This is the left-hand side of the identity we want to prove. And I'm going to expand that. So left-hand side is equal to cotan x times cosine x plus cotan x times 1, that's cotan x, minus cosecant x times cosine x minus cosecant x. Now let's write everything in terms of sine and cosine. Cotan x is cosine x divided by sine x times cosine x. Cotan x is again cosine x divided by sine x minus cosecant x is 1 over sine x times cosine x. And finally, minus cosecant x, we'll write that as minus 1 over sine x. Now note that cosine x over sine x minus 1 over sine x times cosine x add up to 0, so they cancel each other. And we have two fractions, cosine squared x over sine x minus 1 over sine x. So we can write this as cosine squared x minus 1 over sine x. If we look at the numerator and factor out a negative 1, we'll have minus 1 minus cosine squared x over sine x. Using one of the Pythagorean identities, 1 minus cosine squared x is sine squared x. Then we have minus sine squared x over sine x. One of the signs cancels out, and we're left with minus sine x, which is precisely the right-hand side of the equation. So what we did is we started with the left-hand side, manipulated it, and showed that it's equal to the right-hand side. And that proves the identity. Next, let's prove the identity that sine x plus cosine x together over secant x plus cosecant x is equal to sine x times cosine x. In this example, we can start with the left-hand side, manipulate it and make it look like the right-hand side, but that's quite tedious. Instead of doing that, I'm going to prove an equivalent identity. So I'm going to start out by saying that sine x plus cosine x divided by secant x plus cosecant x equals sine x times cosine x. This is true if and only if the following equation is true. Namely, sine x times cosine x times secant x plus cosecant x equals sine x plus cosine x. Where does this equation come from? So let's call this first equation equation 1 and the second equation equation 2. So I'm claiming that equation 1 is true implies equation 2 is true, and conversely, if equation 2 is true, equation 1 must be true. Well, let's see. Assuming that equation 1 is true, simply think of sine x over cosine x as sine x over cosine x times 1 and cross multiply. If you do that, you wind up with equation 2. So we showed that if equation 1 is true, then so must equation 2. Conversely, if we start with equation 2 and divide both sides by secant x plus cosecant x, you will see that you would wind up with equation 1. So that proves that if equation 2 is true, then equation 1 must be true. Now that we've established this, instead of proving equation 1, I'm going to prove equation 2, which is a lot easier. So let's start out with the left-hand side of equation 2 and distribute. So the left-hand side becomes sine x cosine x secant x plus sine x cosine x times cosecant x. We have sine x, cosine x, and secant x is the reciprocal of cosine, so secant x is simply 1 over cosine x plus sine x cosine x, and cosecant x is the reciprocal of sine x. Now note that cosine x times 1 over cosine x, that's simply 1. So our first term is simply sine x. And in the second term, sine x times 1 over sine x is simply 1. So the second term is cosine x. And that's the right-hand side of equation 2. We've established that equation 2 is true, which is equivalent to equation 1. So equation 1 must be true. And that proves our identity. Next, let's prove the identity that tan squared x minus sine squared x equals the product of tan squared x and sine squared x. Let's start with the left-hand side. And write tangent squared as sine squared x over cosine squared x minus sine squared x. So I simply converted tan squared to sine squared over cosine squared. Now if you look at those terms, they have a sine squared x in common. Let's factor that out. We're left with 1 over cosine squared x minus 1. Now 1 over cosine x is secant x. Then we have sine squared x times secant squared x minus 1. Now let me remind you of a Pythagorean identity that secant squared x is equal to 1 plus tangent squared x, which means that secant squared x minus 1 is none other than tangent squared x. So I'm going to go ahead and replace secant squared x minus 1 with tangent squared to have sine squared x times tangent squared x as our final answer, which is precisely the right-hand side of the identity we are trying to prove. And this proves our example. Finally, let's prove the identity 1 minus cosine x over sine x plus sine x over 1 minus cosine x equals 2 times cosecant x. We start by looking at the left-hand side, and I'm going to make the denominators common. So we start with the first term, 1 minus cosine x over sine x. I'm going to multiply this fraction by 1 minus cosine x over 1 minus cosine x plus the second term, which is sine x over 1 minus cosine x, and I'm going to multiply this fraction by sine x over sine x. Simply doing this to make the denominators equal. So we'll have 1 minus cosine x, 1 minus cosine x, plus sine x times sine x over sine x times 1 minus cosine x. If we distribute 1 minus cosine x, 1 minus cosine x, we wind up with 1 minus 2 cosine x plus cosine squared x. Plus sine x times sine x is sine squared x, all divided by sine x times 1 minus cosine x. But recall from the Pythagorean identities that cosine squared x plus sine squared x is simply 1. So I'll replace that with 1 to have 1 minus 2 cosine x plus 1 divided by sine x times 1 minus cosine x. Moving on, the last expression is equal to 2 minus 2 cosine x divided by sine x over 1 minus cosine x. If we factor out a 2 in the numerator, we have 2 times 1 minus cosine x over sine x times 1 minus cosine x. Notice how 1 minus cosine x cancels with 1 minus cosine x to leave us with 2 over sine x, which we can write as 2 times 1 over sine x, and recall that 1 over sine x is none other than cosecant x. So we have 2 cosecant x, which is the right-hand side of the identity we're trying to prove.